So I'll notice that my leg is 495. So I'm just gonna click here, go to my 495, and then start designing from the ends of it. I'm gonna toggle back to my 45mm increments. Like that. And here I'm gonna check how long this is. This is 630. And it's right in between my two legs, so that's where I'll be placing it. Here, like that. And then like that. So something I like to do is actually, if I have a linear pattern that I would like to reproduce, I actually like copying and pasting it so that I have the exact same thing. Everything's gonna stay connected with each other. And I'm just gonna move it like that. And then I'm just gonna slide it, detach it if I don't have that degree of freedom that I want, and then reconnect it so that I do have that degree of freedom that I wanted to slide it in, because I wanted to slide it in the vertical. So that's another trick that I wanted to show you, is just this attach and detach feature. So detaching these parts mean it's going to detach all the connections on these parts. Detach only selected parts means it will only delete the connectors between these two parts. And then here, I'm going to double check how long this is going to be. And this is going to be 585. So I'm just going to resize this one here, and then just resize it as I place it. And there, that's pretty much my frame. So I'm going to start working on the legs here, because I notice I have some anchors that where there's going to be a horizontal extrusion where the anchors are going to be located. So I'll start with that now. And I'll do the same trick. So this is going to be 315. I'm going to take the same extrusion using the I shortcut, and then just resize it like this. And then I'm going to resize the other end so that it's kind of centered. And then finally, I can do my adjustments, my final adjustments here. So I have to switch in between my increments to get it so that it's located at the very center, like that. And I'm going to do the same for the rest of the two. Like so. And then I'm just going to detach this one because I think I don't have the proper connection. So I'm going to detach selected parts, and then I'm going to manually move this part. I'm going to detach this and then manually move this so that it's kind of in the right place, and then I'll reattach it like that. So how I selected two components is I was holding on to control, and then I was clicking this one, and then I click the second extrusion, and then here I'm going to right click on my mouse and attach selected parts. And then what I like to do here is I like to go into a different view so that I can see my part right here just lost in the cat a bit. Making sure that everything is properly centered. So notice when I go into the front view that it's actually not properly aligned. So I just go to the very end and move it there so that everything is flush with each other. So this is just kind of a good check to make sure everything's symmetrical, nothing's kind of offset, and everything's properly aligned. So here, I'm gonna toggle between my degrees of freedom, and you'll notice that I have these options, 2 out of 7. So when I click my left and right arrow keys, it actually toggles through these options for me to slide my part on. The reason I'm sliding these parts is because I want this extrusion to be connected on my vertical as well as my horizontal leg. It just keeps a better connection. Like that. So now it's quickly connected like that. So now I'm going to start with the floor anchors. And here, you're going to notice that you'll have to tap these 4 holes, and then these ones are just going to be resting against the T-nuts on the extrusion slots.
It's looking pretty great.
Thank you.
That's my little artistic input to this. It's looking really great.
Thank you. Well, here I also noticed that I have some gussets that I have on each of my legs. So that's where I'm going to begin. And these are going to be HP gussets.
Your favorite.
My favorite.
Are there other gussets that we can choose from when we're mounting the floor anchors?
Yeah, absolutely. So let me show you that. So I'm going to do it on the other side. So we also have GP gussets. These are our regular gussets. You'll notice that here, if I do a comparison, that these ones do not have locators on them, and then these ones do. So this is the one I prefer, just because it makes alignment easier.
Mm-hmm.
Another tip I wanted to show you is we actually utilize our mirror robot mounting blocks quite frequently as a type of connector too. So if you want like a heavier duty connector, you can use these ones like that. And these ones also have the locator. So if I detach it and I show you the back of them, they also have a locator.
Oh,
Like that.
very cool.
Frequently you can also use these as floor anchors if you don't want to go for the heavy duty floor anchors. So you can just anchor these right into the ground, and they also have that slot for that little bit of adjustability that you might need.
Great tip.
You might notice that I make some mistakes, actually pretty frequently. So I love using the Control Z. So that just undoes whatever I did, or I just delete it, whatever my finger is closer to. Here I'm going to connect these at the ends as well. I'm going to slide it up. And same thing for here. And then I'm just going to slide it up. And you'll see that the range extender is coming along. It's kind of getting formed, similar to the one that we have here. So here, I also noticed that I have these gussets. So I just want to finish off all my gusset connectors so that I get that out of the way and I can just easily use I. I'm going to do the same thing on the other side. Oops.
So many gussets.
Yep. Yeah.
I just want to take this time to see if there's anybody that's listening to us on this webinar, that they have any questions on what Vivian has already presented. Again, just send us your questions through the Q&A icon at the bottom, and we'll get to them as soon as possible.
And we're almost done here. This is going to be the last one with the gusset connections. Again, you can also do the copy and paste if you wanted to. Like so. So now the bottom is pretty much connected. Here we have a good location to place a assembly plate, just to join everything up. And here you'll notice that I have that as well. So here I'm going to use a 2x4 plate to join the horizontal extrusion to the vertical one. So I'm going to go back to my structural and framing and just rotate that there, place it there, and place it on the other extreme as well. And then I also have some just bracing in the middle. A tip that I wanted to show you is if you want to keep everything kind of aligned and symmetrical with each other, you select these to kind of a mutual point where there's going to be a good reference of where it's going to be located. So now I know that this, and this plate are going to be in line on the same plane because I'm using this extrusion as a reference point. And basically the reason I'm doing that is now I'm going to multi-select these 4 assembly plates and then slide them along so that I'm ensuring they're going to be on the same plane and the same level. It just makes it so that the design's a little cleaner in terms of looks. And then basically I did Control C, and then I'm going to do Control V, and then I'm going to have all these plates lined up. I'm going to group them since they're not connected to each other, and then now they're moving along with each other. And then now I'm going to go here and then just drop that in there and then realign everything like that. It's a pretty good shortcut if I know that everything's going to have equal spacing with each other. And then I'm just going to ungroup it and then use my favorite connection checker, and then it's going to connect everything back together and auto-generate those connections. Like that. And then I'm going to start working on these assembly plates from the top here. So I have some T-joints as well as the 90 degrees. So I'm going to start working off of that.
We have 2 questions, Vivian.
Oh.
So Adam, thank you for sending your question. He would like to know if there's going to be additional gussets available in the future, specifically double wide gussets.
Double wide gussets. So Adam, thanks so much for asking a question. Are you saying having gussets so that they're the same as this, except this is going to be one part? Is that what you mean? Yeah, so we can definitely add that onto a roadmap. This is a great suggestion. We always take user feedback and try to generate the parts that you would want to see on the CAD platform. So we'll make a note of that and make sure that if this is a high popularity item, that we're going to include that. Just out of curiosity, if you want to let me know later, that would be great too. Is it just for convenience so that you have less parts to work with, or is there any other advantages you see in using double wide? Okay, great. Thanks so much, Adam.
And then we have an anonymous question. Someone would like to know how to multi-select. If you could show that later, that would be great.
Yeah, let me multi-select these parts actually. So I'm gonna multi-select this by clicking on it. So I'm just left clicking on one of the parts, holding control on my keyboard, and then clicking a second part. And then while I'm still holding down on control, I'm left clicking on another part. So that's how you multi-select. So now that we have everything for the base and the structural aspects, I'm going to show you the tip about the linear actuator. So I'm going to slide this extrusion out of the way, and I'm going to go to my categories, go under linear motion, go all the way down to my 2295 belt actuator. And I'm going to place it there, like that. And I'm going to re-slide this part back in. The reason being is we currently in the CAD, it does not show that we have the option to make the belt actuators using the heavy duty. However, we can definitely configure that and customize that for you. It will just make your linear actuator stronger, and you in this compact version, it just reduces the footprint of the range extender. So here you'll see that we have an interference. But basically, we're just subbing in the double extrusion for a quad. So don't do this and purchase it, but actually notify us, and then we can make that adjustment for you as we prepare your order. Basically, what you could do is you can request design help, and you can also use this pin feature, this comment tool, pin the location and tell us sub extrusion for heavy duty, and then submit it, and then we'll know what you mean, and we'll make sure that we get that done for you. It's going to be pre-assembled, so it won't be a detached assembly. You'll just need to join the belt at the end and connect the tensioner with the belts. So yeah, that would be the linear actuator tip I would like to show. And then here I'm just going to add in my motor and add in my encoder. And then I'm going to start building the carriage. And I always like building off of the carriage using the gantry plate. It's because it will auto snap to the belt tensioner, and this is how I'm going to be able to simulate my machine logic. So here, this is going to be 360. So I'm going to go back to my extrusion profiles. And then slide it back. And then do the same thing. And then slide it.
We also have another question. Someone would like to know if our software contains all the standard components related to fixtures, jigs, and trolley, and even BIW fixtures.
Oh, we do have a library full of these fixtures and tooling components. You can actually find it here under fixtures and tooling. And these are just some of the components. You can select them. There's some jig locators. We have these rest buttons as well as tooling balls. We have clamps, locating pins. Is there a certain component you would like to see?
We'll wait till we get that answer back in.
Yeah.
But thank you for showing us that. It's true. We also recently written a blog post about how to create your own jig fixture as well in a step-by-step process. So if anybody's interested, head over to the Vention blog and look up that, and it'll walk you through how to build it and the different parts available that we have in the CAD.
Okay, great. Here I'm going to place my linear bearings here. You can do this first, or you can do this after you put in your linear guide rails. It's definitely up to you. I just selected the bearings just because I was already there and I was working on the gantry plates. So here I'm going to scroll down to my 2295, and I'm going to place that there and then slide it all the way. Here I selected the wrong assembly plate, so I'm just gonna toggle through and click this one so that there's no interference, and then slide that along. And I'm gonna do the same thing for the other side. And then just slide that all the way to the end. And we're almost done. We just have to add some end sensors here, some homing sensors as well. And then you can find that under your motor and controls. So I'm going to start here since I have the motor. And you'll notice that I'm placing it on the inside just so I'm saving a little bit more space. Placing it here, and I'm using inductive proximity sensors. And then we can't forget our controller. It's going to be a plug and play solution here. And basically, we also need to include our UR cap. And the one I'm selecting right now is going to be the robot cell integration. And this one will just allow me to use my encoder along with the UR cap. And it will also allow me to move my UR robot with my range extender at the same time. So it does help a lot with cycle times.
And this is something that we just released last month, I believe. And you could find more information on the Vention blog as well as on our YouTube channel. We also did our previous webinar on how to build a robot integration cell using the robot integration kit.
Thanks. And now I'm going to drop in the robot from our partner parts. So here we're going to go into Universal Robots, and we're going to select the UR10E. So a lot of you were asking us to just create the connector for all our robots, so we did that, and now it just auto snaps to our plate. So that's pretty much it. There we have it for the UR.
Awesome.
Yeah, so now we're going to work on our last subassembly. And again, we're going to use the connection checker just to make sure everything's properly connected. And then I'm going to do my test, make sure everything's not floating, move that out of the way so that we have a little bit more workspace. And then now we're going to design the inspection system.
Before we head off, he would like to know, the jig fixture would be for body panels or door panels as an example.
Oh, we have various types of panels that you can choose from. So basically you will have to build a frame, and I'll do this along the way actually so that I can show you how that works. So here, this is going to be 1035. So basically I'm just going to build a frame around so that I can generate a panel for you. So just bear with me a moment. We're gonna
Just working on the fly. You could build a panel, you could build a frame in like 2 seconds.
making sure that all these parts are properly connected. You can then generate a panel, and then you'll have various panels you can choose from here. And then basically you just build that. You can build it on the outside or the inside. The inside option will just auto-generate the panel so that it's resting inside the slots of the extrusion. So you don't require any fasteners in that method. On the outside panel, you can create the panel, and then we could add some countersink holes with the included fasteners that will be generated in your bill of materials. So you can select that. So those are some of the panels that we offer. If there's any that you believe you would need for your fixture, please let us know. And again, we would love your feedback.
Awesome. Would there be a way to see real pictures of our various panels options? I know that.
Real pictures?
Yeah.
So for an example, you want to, yeah, absolutely. We could take some pictures that we have on the floor for you if you would like. Is that what you mean? Then you can see the finish as well. So yeah, we would be more than happy to do that for you if you ever need that.
Great.
And thanks again for asking all these questions. They're super appreciated, and we'd love to answer anything else you might have.
Mm-hmm.
So again, I'm just building the frame. Here I'm using a ball screw, and I'll show you how I'm configuring that. So I'm going to move this out of the way so that you can see a little better. The ball screw is an 855 ball screw, and I'm going to find that under my linear motion. I'm going to rotate that so that it's vertical. And then I'm going to take this extrusion and pop that in there in between. Like that. And then I'm going to snap on a gantry plate onto the housing, and then add my linear bearings on the side, like so. And then again, love using the linear guide rails. Just gonna put that into the model as well, slide that down, and then do it on the same thing on the other side, and then slide it all the way up. And this is pretty much your ball screw. It was pretty easy to configure, just a few parts to kind of snap together. And when you have a vertical configuration for your linear motion, we always recommend putting a brake on it. This brake is not a dynamic brake. It will just activate in case of a power loss. That's only when it would activate. So now I'm going to use my manual constraint, click this connector and place it over here. Snap it into position, like that. I'm going to resize this. And then I have this kind of sandwiching the ball screw. The reason why I'm making these separate is so that I have a little more adjustability for my linear actuator. So if I ever need to kind of align everything, it's separate from my frame. And that's kind of a design tip that we would recommend you doing. You could always configure the ball screw if it needs to be a heavier duty structure. You can configure it with our quads as well, our heavy duty extrusions, and kind of have that on the side as well. So it could be like that. And then I'm just going to add some end caps at the top there since I already have the frame done. I'm going to move that back to my other side so that I can reference it. So here, something to keep in mind would be the adjustability as you're designing. You always want to keep it as adjustable as possible. What you do is, instead of putting everything on top of each other, you want it so that it's riding along the extrusion length, just so that you can move this up and down if you ever need to. And since that's where we're going to be placing our camera, you want that to be a little height adjustable in case you wanted to position it in a certain way. So this is where I'm going to be placing the camera. So I want to make sure that I can slide this side to side as well. But that's just a design tip that we encourage to keep in mind as you're designing.
And that's also something that you guys perform during when you have a design review done by our team, correct? So you guys always optimize for as much customization for the builds that you guys are looking at.
Yeah. Michael's going to be an app eng soon.
Very soon, very soon. This is webinar number 5 or number 6? I think number 5. I'm almost there. It's a crash course.
Now I'm just going to build off my carriage right here. Here I'm using a single. I'll let you know why I'm doing that. So I'm just going to connect that to the ends, snap it on, and then resize that to fit the footprint of my gantry plate. And then I'm going to use these double extrusions to build my carriage. And let me measure what I did here in this model. 270. Have 270. And then I'm going to resize this one. And then I'm just going to use my 1x5 to close it off at the end. And here, to connect everything, I'm going to be using 2x5s. So just connecting it at the end here. And then I'll add my end caps as well, just so that no one scrapes up their hand on the sharp edges of our extrusions, like that. So now I'll build the mount for our pneumatic cylinders. Super highly requested parts from our users, so we wanted to showcase that as well. So you'll be able to locate these cylinders here, and I'm going to use my 200 length. I'm going to detach it and kind of just move it this way. And you can actually simulate the movement of the pneumatic cylinders too. They have the closed and open position like that. And here we're going to also add our end piece. And this is where you can connect our extrusions so that you can build a pusher, which is what I'm currently going to build and show you how I'll do that. I'm using our light duty just because you don't require any high structural, a strong member. So just for the push mechanism, I'm going to build that and add my frame connector to it. And these are our light duty connectors. I'm going to slide that back up. Like so. So everything's nicely tucked. And then I'll add my little end caps at the end. And just to prevent any scratches on the workpiece that you're going to be pushing off, we would recommend adding these Delrin pads, these rest pads. And that's pretty much it. That's going to be how you're going to mount your pneumatic cylinder. And again, they're going to go through the I/O module. So it's 0 to 24 volts. So it's just an open and closed position. And that's how you're going to signal when to activate it. Yeah.
We actually do have a question.
Mm-hmm.
Is there any real-time recommendations within the CAD, for example, if the robot is too heavy for the part chosen for the fixture and more robust parts if necessary?
You can always ask for a design review, and then we can take a look at it together and then analyze it based on the application you're doing. So because it's such there's so many different possibilities that you could have require an analysis, we could give you our best recommendations based on that.
Great. And then also, can we, someone would like to know also, would the software support plant simulation?
Plants. Sorry?
Like a plant simulation. So I'm guessing a larger, like a robot cell or a larger.
Yeah. So yeah, you can do that all through MachineLogic. So now our MachineLogic is able to control up to 3 outputs. So if you have a plant that's working on 3 outputs, yeah, for sure.
Great.
We actually have a webinar that Michael and Mac did together. If you ever are curious about seeing that and how that's done, we have links posted up as well.
That's very true. Just visit our YouTube or visit our blog and you will find those. You seem to be almost done with this third.
Yeah, almost done.
Yeah. And just under the time almost. So I would just like to let everyone know that we're almost nearing the 1 hour of our webinar. This may go a bit over as Vivian wraps up her final build, but if anybody does have any other additional questions that we didn't answer yet, please feel free to send them through right now. And if you're unable to stay past the 1 hour mark, thank you for joining us. And we'll get to your questions at a later date or in our next webinar.
Thanks. Yeah, it's super appreciated for everyone who's joined today. So thank you again.
We have a question from Paul. Hi, Paul. He would like to know, would you have the cost of the RTU extender system less the controller?
Oh, yeah. So these are all going to be found under controls. So here we're actually going to be placing that in here. So here, this is the module that you'll see, and the prices are very transparent, so you'll be able to see that in our parts library as well.
Great. And then Mark would like to know if the brakes are pneumatic.
No, they're not pneumatics.
Power off brakes, correct?
Yep.
Power off brakes.
So basically they're using an electromagnet, I believe, that will only activate once the power is lost.
Great. And then we have a question from Mark. He would like you to demonstrate how you would package your final design in a format that you would present to a customer for a proposal.
Oh, great question. So how I would package that would be going to the top view, so my plan view, and placing it so that it's in the actual layout that I would have it on the plant floor. This way I'm working based on only one plane, and it would just make it easier to see how everything would look. So here I'm grouping this part, and then placing my inspection system where the end of the robot will be required. So right now, again, working only on the top view, and then here I'm going to make it so that they're all on the same plane in the front view as well. So just the height adjustment, I would be dropping it onto here, and then moving this onto this side as well, just so that everything is lining up. And then basically how I would present to a client would be presenting it in an isometric view just so that they can see how everything looks like. But this just keeps it nice and neat for the client or the end user to see. And after you're done everything, I always recommend taking a thumbnail so that you can recognize your design based on the isometric view. Thanks for asking that question. So now finally, we just need to add the DIN rails for our bin. And you can actually find that in our public parts. So here, this is not included, but you can move that there. And then on the side view, you can place the bin like this and like that. And if you ever need to, Mark, if you wanted to export it into a PDF, we have this tool where you can download the instructions and it will auto-generate the isometric view of your system, as well as our, so if that's the layout that you would like to send. If you want to send the link and open it up in the MachineBuilder, you can add them as a collaborator, enter their email, and they'll have full access to this design. If they don't have a Vention account, you can always use and generate a link with price or without price. So without price, you just copy this link to them. And then once they enter that into the browser, they can view the file as well. So those would be some of the methods you could share. So this is going to be my good bin, and then I'm going to need my bad bin as well. So I'm going to group these so that they're together, and then just kind of move them so that they're properly connected there. And then I'm pretty much done the design. We'll just have to finalize the pneumatic parts. Yeah.
That's great. You did it within 1 hour, 3 assemblies with partner parts, with pneumatics, with a bunch of gussets. It's perfect.
Thanks. So yeah, when we're using electric cylinders, we'll always recommend adding our air valves as well as the manifolds. So if you have two separate outputs that are not going to be synchronized together, you'll need the 2-valve pneumatic manifold. And then here, this is just, you can turn it off and set the pressure that you want for your pneumatics as well. But yeah, that's pretty much it. And these are going to be your I/O module where you're going to be controlling the sensor here to detect the part, as well as your pneumatic cylinders. And if you have a camera system that accepts the I/O module, then you can use that as well. Is there any questions?
No, it doesn't seem that there's any more questions. I would like to thank all of you for attending this webinar and listening to Vivian put this assembly together. As I said before, you can always reference our blog to stay up to date with all of the newest things that are on Vention, including software, hardware, and automation. Also, if you have any other questions that you'd like to send us about this webinar or just comments in general, always reach out to us at marketing@vention.cc.